So for one, it says a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by this function. Negative 16t squared plus 64t plus 80. At what height is the rocket launched? What point would this represent on the graph of the function? So, where the starting point on any quadratic function is always the y-intercept. Okay? So looking at this function, remember when it's standard form, the y-intercept is always the c. So long the rocket's starting height where it was launched was 80 feet. And it even says in the directions, it was launched 80 feet above the lake. And as you can see, that's the y-intercept. What is the height of the rocket after 1.5 seconds? Again, we can use our graphing calculators to find this. I'm going to go to y equals. On my graphing calculator, clear out what's there, type in the function. Negative 16t squared plus 64t plus 80. And again, notice how it says t, negative 16. Just hit the variable button, and it's next to the green alpha button. We just need a variable there. Plus 64 plus 80. And hit graph. Again, we can't see this graph very well. Okay? We'll adjust the window in a second. I'm going to do zoom 6. Get a normal standard window. Okay, so we can't see everything of the graph, but we don't really need that to find the value. I can just go to second trace value and type in 1.5. And do you see the height? It's 140. Okay, so we don't really need to see the whole picture to do that. So 140 feet. And again, we got that using our calculator. Steve says, what is the maximum height reached by the rocket? How long has the rocket been in the air at this point? So we can adjust our window, or you can also just do zoom out and see if that helps. And it doesn't. And if you keep zooming out, it's just going to be a goofy picture. So let's change our window. Let's think about it. We know the rocket started at 80 feet. So it's going to go higher than 80. So I'm going to change our y-min. We know it started at 80 feet. Oh, I'll just put 5 there for now. We know it started at 80 feet. So our y-min needs to be at least 80. I might put 75 just to get a good picture. No, sorry. Don't put 75. Put like 0. Or like negative 2. Just to go a little bit past 0. Okay? We know for our y max, it was launched at 80. So we know our y max has to be higher than 80. So think about how high would a rocket go. And again, guess. I'm just going to say 500. And I'm going to go by 50s. I'm going to go by 100. Again, we might have to change that y max. We're just guessing and checking. But we know it has to be above 80. For our x max, we can kind of see, and when we look back at the picture, we could see that it landed in a 10 by 10 grid. So I know I can just go from like negative 5 to 10. We know where it landed, right? So sometimes graphing, it gives you an idea of what your y, your min, and your max are. So I'm going to go ahead and hit graph. And there we go. 500 was way too big, but we can still see the picture. We can change the window and make it like 200 or 300. Make it even better picture. So there we go. That's where our graph is. And we want to know, what is the maximum height reached? So when we ask for the maximum height, we need to find the maximum. So you hit second, trace, max. Go a little bit to the left, a little bit to the right, and then guess. So the maximum height is about 144 feet. Right? The height is always the y value. So the max height is 144 feet. The x value tells you how long, and the x value is saying around 2 seconds. So it took about 2 seconds to reach the height. So the maximum height is 144 feet, and it took about 2 seconds to get there. D says how many seconds after it is launched will the rocket hit the lake? So whenever it lands, that's always the x-intercept. So to find the x-intercept, we still use that 0 tool. You're going to hit second, trace, 0. And again, go a little bit above. Go a little bit below. And guess. And stop. After about 5 seconds, that is when the rocket will hit the ground. There's number 1. Number 2 says a football is thrown to a receiver 40 yards away. The following quadratic models the path that the football takes when it leaves the quarterback's hand, where D is distance from the quarterback in yards and H is the height measured in feet. How many yards from the quarterback does the football reach its maximum height? So this means we want to find the x value of our vertex. Because we want to know when the football will reach the maximum height. In other words, we're figuring out how many yards it will take for the football to reach the maximum height. So we have to find the maximum. So let's go ahead and plot this into our y equals. Negative 0.025x squared plus x plus 5. Yes, there's these there, but we're just going to use x plus 5. I'm going to hit zoom 6 to get a normal graph. As you can tell, we can't really see how far or where it landed or what's next. So we have to kind of adjust our window. So let's think about the scenario. Okay? We threw a football. Clearly, it's going higher. Clearly, it's going higher than 10, and it's going further than 10. So our answers have to be 10. So just think about a football. I'm going to guess, and again, sorry, hit window. Keep clicking the wrong thing. Our x max, I'm going to make it like -5 for our min. We just have to figure out what our max is. A football field is 100 yards. So he's not going to throw it further than 100. So let's say like 50. And we'll count by tens. Okay. Y min, again, I'm just going to make that -5. Get a good picture. And the max, okay, well, it's going higher than 10, but it probably can't go much higher than 10. So I'm going to put 20 and count by 5. And there we go. So kind of have to think about the scenario. Think, okay, a football field's 100 yards, so it's not going to go further than 100. It's really hard to throw a football a full 100 yards. Just gonna have to play around your window that way. Think about the scenario. So now we have a better picture. Now we can find the maximum. So you're gonna hit second, trace, maximum. Go a little bit to the left, a little bit to the right, and then enter. So roughly, I'm going to say that's 20. So this is about 20. It took 20 yards for the football to reach its maximum height. What is the maximum height? Well, that's just the y value of your vertex, and that's 15 feet. Remember, the vertical distance is in feet. The horizontal distance is in yards. C says the receiver misses the throw by a few feet. How far from the quarterback does the football hit the ground? So we have to figure out, well, what's the x-intercept? We need to know, here's where it hits the ground. That will tell us how far. So to find the x-intercept, we use that 0 tool. Okay, so we get second, trace, 0. Again, we're approaching this from the left. So we are going to start above, a little bit above, hit enter, Go below, hit enter, and hit enter again. And again, when you get this goofy thing, this just means 0. So it's a roughly about 44.49 yards. Or 44.5 yards. There we go.